efficiently. In this video, I am going to tell you all about what you have to do in the event. So make sure you watch till the end to understand everything clearly. Let's get started. Now, what is machine learning? Machine learning is a part of computer science where computers learn from examples or data. It helps them to make decisions or predictions on their own without being exactly told what to do. For example, imagine you keep trying to find out the best way to eat a sandwich without falling it apart. But after a few messy dips, you learn the perfect way to hold it. Just like that, computers can learn from past data to make better decisions next time. Machine learning is like how humans learn from experience. So everyday examples, you probably use machine learning every day without even realizing it. When Netflix suggests you a new show, you might like it because it's analyzed what you and millions of other people watch. That clever autocorrect on your phone that fix your types. It must learn from the words you type most often. Your voice assistant, like Siri or Alexa, get better at understanding you the more you talk to it. How does it work? It is a simple three-step process. Collect data to gather a ton of information like vectors, words, or numbers. Train the machine. The computer looks for pattern in that data. For example, in notice, the most picture of cats have pointy ears and make predictions when it's learned pattern. It can use that knowledge to make smart guesses or decisions on its own. Imagine you're teaching your imagine you're trying to teach a computer to do something like a simple task such as finding a picture of cat instead of writing a super long list of rules for what the cat looked like. You just show the computer thousands of pictures. This is a cat, this is not a cat. Like this labeling, over time the computer learns on its own to spot the pattern that makes a cat. Machine learning is basically a way of teaching computers to learn from examples just like we do. Why should you learn machine learning? Machine learning is not just for tech experts. It's used in so many cool fields. In healthcare, it can help doctors find diseases earlier. In finance, it helps detect frauds. And of course, it's what makes self-driving car works. Learning about machine learning also helps you build important skills like problem solving, critical thinking, which are useful no matter what career you choose. How you can get started with machine learning? Learn Python. Learning Python is the basic step you need to do to learn machine learning. And stay curious. The most important thing is to be curious and have fun experimenting with new ideas. Now, the next step, now that we know how it works, let's get hands-on and build our very own machine learning project. It's time to put theory into practice. Let's get started. Open your Chrome browser and type Google Colab. Enter. Here you will see the very first link. Click on that. Mine is already logged into Colab, but whenever you start making a new notebook, you need to first log in and create your account on Google Colab. This is how it will look when you create your own notebook. So here, this is what a Google Colab interface look like. You can change the name of the file from here. Like I'll write here Dataverse event. If you wanna write anything regarding Python, let's initialize a variable with 10 and we wanna run this cell. We'll press this button. This is successfully run. If we see this tick, it means the cell is successfully run without any error. Let's print the value in A. Here we got the output N. So this is how Python works. We'll share you the link where you can understand the basics of Python. Now we'll see how we can clean a data. Data in simple terms is the information or the fact we collect. It is a raw material that machine model use to learn and make decisions. Here in this project of machine learning, we have tic-tac-toe data. Here how our data look like. What using this data will teach the machine how to make predictions. These are all predicted values. We'll let the machine know these are all predicted value. When you play like this should be the output. When lost, we'll teach the machine in this. So now let's understand what this column means. And we all know how to play tic-tac-toe game. Let's see the example. Here's how a tic-tac-toe games look like. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cells we have. We need to place our symbol in such a way that it creates a straight line, either diagonally, straight up or down or bottom or middle. Doesn't matter, just a straight line. It's a 3 into 3 matrix with 9 cells. I have took one example of our data here for TL. What is this TL means? This TL means here we'll see this is our tic-tac-toe board. Top means this is the top row, this is middle row, this is bottom row. This is left side, this is middle, this is right side. So this cell name will be top left. This cell name will be top middle. This cell name will be top right, and so on. Now we can see we have cross zero B somewhere written. So what does it mean? Suppose we have symbol X is for human, for us. The machine took a symbol of zero, machine computer. And B means the black or the empty cell. This doesn't contain any symbol, not from the human side, not from the machine side. So if on the top left cell, the human have put it the symbol. So we write the symbol of human for us. And the top middle side, machine have same way we'll do top right, ours, or top right and middle left is ours, and middle is machine. The middle R is again for machine. The bottom left is ours. And the rest of the cell, bottom middle and bottom right, this bottom middle and bottom right are blank. So who win the game? Straight line. Who win the game? We won the game. The humans won the game. This what a cell consists of. This what a row consists of. In the class, the output. This tells how if a human wins, it will write true there. If the machine wins, it will state false there. Now the data is clear to us. Let's proceed towards how we can use this data to train a machine. Train the machine with the data. First, we'll need to look at the data. How a data looks. If we see from second to fifth row, every column has some of the other values. But from sixth, seventh, eighth, ninth rows, we'll find there are some of missing values. These missing values can create error while we train the model, and the machine learning model will not understand anything if we have this missing values in a dataset. So we need to handle this value. To handle this value, we need to first reprocess the data. Reprocess means clean this data. We need to clean this data in such a way that we'll not get any error. The machine will learn and understand the data very clearly. We want to clean this data. There are two steps. The first is First step we can do is just delete the unwanted row. Unwanted row, the column, I mean the row which has missing values, we can delete this row. Very simple step. We can just cut off this one. And the next step we have the most frequent value. We can fill this rows, the cells which are blank, we can fill this with the most frequent entries we have in that column. Let's suppose in column A, we have X, 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 X. The very first thing we have X, X, X. The X entries are very high, and it tells us that X, the symbol X has occurred a lot of time, the most frequent one. So obviously, if we got to know that we can replace this blank cell with X will not get any error. Similarly, the in column B, we came to know that X is the most frequent symbol, so we can replace this empty cell with X. And similarly, with every column, we can do this. These are two main steps we can do to pre-process the data. This is what all theory is. Now let's implement this in a Google Colab notebook, and let's see how to do this. This is a CSV file. This contains rows, columns. So for this kind of document in the Google Colab, we have a library called Pandas. So we'll import that library, import Pandas as PD. Using this library, we can work on the data, on the data, on the data means the CSV file. Using this library, we can work on CSV file. Here in Python for comment, we don't use slash slash. Instead, we use the symbol. Now it will run successfully. We got this tick. It means the pandas library are imported successfully. Now, where you get the tic tac toe data, like this data from where you look at. So you can just Google it. Type here kaggle.com, kaggle.com from the search bar, search data was tic tac toe. Enter. You will find this thing. Click on that. Hit the download button. Here you will find download data that has zip. Click on that. Here you'll see it down. Double click. Here you can find your data. This data is in zip file. So in the downloads, you need to extract it. To extract this file, you need to right click and here you'll find extract all. Just click on that and then hit extract. The data gets extracted. In the downloads, in this folder, you will see this file. Now you got the data. Let's see how you can bring that data into this notebook. So to get this data, loading this data, you have PD. This is an alias to this pandas. PD is an alias to this pandas. Okay, I hope you know what alias. Alias is pd.read underscore CSV. This thing will read the CSV file. CSV file, CSV file, the Excel file we have. And here in the bracket, you need to give the path of path of the data, path of the data. This thing will read the file, but we need to store in some of the variable. So we'll declare df. We'll store all this data into this df variable. So how we'll bring the data to collab file? Here you'll find the symbol, files, upload, Go to downloads. Here you'll see where you have downloaded. Here you can see your TikTok post, or either you can hit search and search it. Okay. Your TikTok CSV file is loaded. George, when you place the cursor on this file, you will get three dots and then copy your path. Paste your path over here. Control V, path is pasted and run. The data is successfully run and stored in this df variable. If you want to see the data, just write df because in the df variable data is stored and run. You will see the data. This is what we have in the Excel. This data is get loaded on this node. Okay. Next, we need to fill this column, fill this cells with the most frequent occurrence of symbol. This we why we didn't choose to drop this rule because it's not a good practice in machine learning. Either we can fill it with mode, the most frequent one, or with the mean value if we have numbers, or with standard deviation of variance, we can fill the row. I mean the cell. Here we will fill with mode because we have characters. Characters means alphabet. So how to fill this? First, we saw the data and we know where's the missing values and how is the missing. But when the data is too large, we don't know where's the missing value. So first we need to check where is the missing values. Checking the missing values. Okay. So to check the missing values, we have uh we have stored the data in df variable. So check in data if any null column is there, and if it is there, then how much? Some. Now on this, you will get to know in TL column you have one empty cell, in TM column you have one, in TR1, in MM in two, BL1, MR1, PM1, PR1. So what another there are missing values. Null values means missing values. Now the next step is to fill those values with the most frequent entry. Which fill the missing values with most frequent entries. Okay, so we'll put a loop here in df dot columns, right? Full columns, then df call equals to df call dot fill the empty cell with the most frequent entry. Cell is done. Let's see if our columns are filled or not. Let's check it manually. Then we'll check with this same code. Missing values. Let's check manually. Just here, run. We'll see in fourth column there are no empty cells. Now let's check with coding. Okay, so I'll just copy paste this. You will find 0, 0, 0, 0, 0, 0. No empty cell is there. It means the data is successfully preprocessed. Now we can use this data to train our machine to take that with us. Now let's jump to machine learning, where we'll make a real world model. Now you'll find some statements here. What are the statements? I give you an example. If you want to make a car, what are the materials required to build a car? Like engine, tires, brake, clutch, etc. That are essential things to build a car. Even if one of the thing is missing, the car will not work. Same way, the statements are must to write in order to build a model. The statements are material in case of model. Here you will see decision tree classifier. This statement is engine of the model. Just like we cannot start a car without engine, yeah, we cannot build a decision model, a machine learning model without this statement. And this statement will tell us what is the accuracy of a model, how much it has learned. Just like we give exams in school and the report card comes with percentage we got in the exam. Just like that, this is the accuracy. And obviously to work with CFP or fill file, we need pandas. This is to convert the categorical values into the numerical ones. The machine does not understand human language. We need to decode it to a numerical form. So this statement is used to convert the category, the alphabets, the statements to numeric form that machine understands. And this is for GUI somewhat. You don't need to worry about that. Sure, converting categorical values to numerical. Here we convert the categorical value to numerical. Now you wonder where is the categorical values. So in the data, here you see X, B, X, O, O, O. These are all the categorical values which will need to convert to some numerical values that machine understands. And this two will convert to one, and this false will convert to zero. And I hope you know how true is converted to one and false is converted to, because in first standard we all have learned adder, subtractor, etc. I'll not go in much deep, but this is how it will work. And convert the categorical values to machine like zeros and ones, which it will understand. This statement will all convert this same thing. Now, feature selection. Feature selection means in this data, this all are the features. This all columns are the features except this column, because this columns predict the output. It means this column depends on all this column, but all of this column does not depends on this column or any other columns in this cell. This column is independent, 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 independent. Every column is independent except this column. This column depends on each of the columns. If the human wins, the output should be true. If the robot wins, the output should be false. So this is how it is. The feature selection. It means we need to select all these features. These columns are features. We need to select all these columns except this because this is output. So we have just dropped this column for a while, not permanently, just for a while we have dropped this column and selected all of this column and stored all of this column to a variable called x. And this column we have stored in the variable y. So this column contains all our features and this column contains the output. Next, we'll build a decision tree. To build a build decision tree, we need to write decision tree classifier. This is the keyword. The keyword you need to specifically write it. Your max depth of decision trees and the random states. The I hope you saw a tree. Let me explain. Tree is this is parent node, leaf node, leaf node for this parent. And then again it can have tiles. This is what a decision tree look like. This parent, this child for this parent, this child. This is leaf node. This circle is called nodes. This is leaf node. This is parent node, child. If the human wins, the output should be true. If the robot wins, the output should be false. So this is how it is. The feature selection. It means we need to select all these features. These columns are features. We need to select all these columns except this because this is out. So we have just dropped this column for a while, not permanently, just for a while we have dropped this column and selected all of this column and stored all of this column to a variable called x. And this column we have stored in the variable y. So this column contains all our features and this column contains the output. Next, we'll build a decision tree. To build a build decision tree, we need to write decision tree classifier. This is the keyword. The keyword you need to specifically write it. Your max depth of decision trees and the random states. The I hope you saw a tree. Let me explain. Tree is this is parent node, leaf node, leaf node for this parent. And then again it can have tiles. This is what a decision tree look like. This parent, this child for this parent, this child. This is leaf node. This circle is called nodes. This is leaf node. This is parent node, child. The random state of 42 means it can have 42 subchilds in the max depth of 6. 1, 2, 3, 4, 5, 6. Yep. And in this fit again a variable will pass our features and the out. The decision tree is completely. We will store this decision tree in this variable, CLF. Now the decision tree model is completely built. Will display the accuracy. The statement will praise all the accuracy, how much percentage the model can predict a correct value, and how much percentage chances are there that it will beat us. So we train the model with the data. Now this is the logic how the computer will play with us. Board of nine, board of nine, board of nine. Then check if winner. If all the symbols are in line, then it's a winner. And then defining the board moves. If there is blank, you can put your symbol in such a way that it comes in lines and you can block the players means if human are winning, you need to block them. But then with the blank cell where they're placing their symbol, they can win. This is the basic logic. It's the basic logic of how the model will play with us. But just writing this statement, we can build a complete machine learning model. Now let's see how how much the model have learned, what is the accuracy, what is the result exactly. We get there unsuccessfully. The accuracy is 84.3%, which is a very nice accuracy. We got this accuracy. Now, what about the game board? This is the code of GUI, which we will be providing to you. GUI means graphical user interface. Most of you will be knowing about this. This very simple and logical thing. Using this GUI, which will provide you this model, the real-time model, is completely built. Now let's play. Let's play. Right. Okay. Oh, shit. We lost. Huh. Once more. Click on. Yes. Free phone. This is how model looks like. Uh, this is from one model we have built this using decision trees. I made this using decision trees. You need to make this using random forest and SVM as well. You will not know or you will not know which model you will get. If you get a random forest model, you will need to make this model like this, train it. You got some other accuracy. We can never say how much accuracy you will get, and obviously zero will be avoided. You using two or three different models, any one of the models you will get to make this tic tac toe game. This game is now built. You can upload this game on GitHub. Type github.com and enter. Mine is login, but when you will be way new to it. You will be really new to this. This is how my sorry, GitHub interface look like. This are all the repositories, the project I did and uploaded it on GitHub. If you upload anything, you get this interface on your profile where all your projects are listed. Upload this project on GitHub, check some YouTube values, YouTube videos to show you can upload your project, the collab file there. Uh, you can also download this file from it. From file, download, download in .ipynb or .py file, which one you prefer, and just upload this on GitHub. Thanks for watching.